Hi, and welcome back to Grade 8 Math. This is Unit 5, Section 6, and the last video for this lesson. In this video, we will look at how to find the missing number in equivalent ratios. We can use our knowledge of equivalent ratios to find the missing number. In the following example, it tells us that 2 to 7 is equal to x to 28. Remember, equivalent ratios are related by multiplication or division. So if these two ratios are equal, then we know that that has to be the case. So 2 would relate to x in the same way 7 would relate to 28. I know that 7 times 4 will give me 28, which means 2 must multiply by the same number. So if 2 multiplies by 4, then that means x must be 8. So 2 to 7 is equal to 8 to 28. Example 2, find the missing numbers. So we have two three-term ratios. We have 5 to x to 4 is equal to 25 to 40 to y. So we're actually looking for two numbers in this case, looking for x and y, one on either side, one in each individual ratio. So I need to find two terms that match between two ratios so that I can figure out what it is that I'm multiplying or dividing by. So 5 will match to 25. So 5 times 5 will give me 25, which means if I multiply each other term by 5, I should get the number in the ratio on the other side. So 4 times 5 would give me 20. So that means y has to be equal to 20. That also means that x times 5 would give me 40. So I can say, well, what times 5 gives me 40? Or if I go the other way and go from right to left, I can say 40 divided by 5 gives me what? So what times 5 gives me 40? Well, I know 8 times 5 gives me 40. If I went the other way, 40 divided by 5 would give me 8. So in this case, x is 8 and y is 20. Example 3, find the missing number. So I have 7 to 21 is equal to 8 to something. So the only two terms that match between these two ratios is 7 and 8. The first terms are given in both ratios. But I know there's nothing I can multiply by 7 or divide into 7 to get 8. So I look a little bit closer and I can see that 7 to 21 can actually be simplified. So I can simplify 7 to 21 by dividing both of those terms by 7. So if I divide both terms by 7, 7 divided by 7 gives me 1, and 21 divided by 7 gives me 3. So I now have 1 to 3 equals 8 to x. So now it's a little easier to find the missing term because I know that I can relate 1 to 8 much easier. 1 times 8 will give me 8, which means 3 has to also multiply by 8. So 3 times 8 would give me 24. So that means x is equal to 24. So sometimes, if you look at two ratios and you're looking for a missing term, if you can't tell, if you can't figure out what you're multiplying or dividing by, there's a strong possibility that you may have to reduce one of your ratios first. Example 4, find the missing number. 10 to 35 is equal to x to 42. When I look at these two ratios, the two that match, or the two that are pairing, are 35 and 42. However, I know that there's nothing that I can multiply by 35 to give me 42 or divide into 35 to give me 42. So again, that's usually a strong indication that you should step back and look at your ratio to see if you can reduce or simplify. In this case, I know I can divide 10 by 5 and I can divide 35 by 5. So when I do that, 10 divided by 5 gives me 2 and 35 divided by 5 gives me 7. So I now have 2 to 7 equals x to 42. Now that I have my ratio simplified on the left, that will relate much easier to my ratio on the right. So 7 to 42, so the two second terms pair up. So 7 to 42, I know I multiply 7 by 6 to give me 42, which means 2 must also multiply by 6. So 2 multiplied by 6 gives me 12. Which means the first term in the second ratio must be 12. At this point, I'd like you to take some time to complete the activities for this lesson.